All right, so you need to understand your shift rules that are happening here. You have a +1 on the outside, so that's going to shift. Remember, we're shifting the parent. You really need to make sure you understand these shift rules. The +1 on the outside is going to shift the parent up 1. We've got a +2 on the inside. Using your shift rule, +2 on the inside shifts us left 2. And a -4 out front is going to stretch by a factor of 4. And the negative part, remember, is going to reflect. Remember, the key is, what are we shifting? So this is the transformed function. The parent, which we're going to graph both of these in the calculator here in just a second, is g of x equals just log base 2 x. So that's the parent function we're shifting. So I'm going to, the log button is found underneath math. So press math, and you can scroll down and you find log base. You've got to use this because the regular log button in the calculator is only base 10. Of course, this needs to be in y equals. Real quick, let's graph that and see what it looks like. This is what's getting shifted up 1, left 2, stretched, and reflected. So now let's type in the transformed function. So it's a -4. Then we go to log base 2, x plus 2, and then +1. And then really we can see that transformation happening. So it got reflected and then shifted left 2 and up 1. Clear out the parent so we can just see the actual function we're looking at. Let's go to the table and graph as many points as we can. So it's -1, 1, 0, -3, 1, -5.34, 2, -7. And obviously we could keep going down and getting more and more points there, but I think we fit as many as we can. And you'll notice this graph is approaching x equals -2, but never actually reaches it. That's why there's an error message starting at x equals -2, because that's where our asymptote lies. So I'm going to sketch my asymptote. It's a horribly squiggle line there. So that's the actual graph, but our asymptote there is at x equals -2, which is one of the things this next question asks for. It asks for the asymptote at x equals -2. The domain for this graph, remember that's how far left and right the graph is going. It is going left. It stops going left at x equals -2. That should be a parenthesis around -2. And that's because the graph never actually touches -2, and then it's going right forever. So much like exponential, the domain was always all real numbers. For logarithms, since they're an inverse of exponential functions, the range is all real numbers. This graph is going up and down infinitely. And then finally, in behavior, so the right end, remember this x approaches positive infinity, that represents the right end. So we look at the right arrow. Is it going up or down? It is going down infinitely. So as x is getting bigger, y is getting smaller. And as x approaches negative infinity, that means we're looking at the left end behavior. So as x approaches left, y is increasing infinitely. So there's our key stats for that graph. Same thing happening on this problem. Our parent function is just ln of x. So we need to understand the shift rules. Plus 3 on the outside is going to shift that parent function up 3. Minus 4 on the inside is going to shift us right 4. And the 4 out front is going to stretch by a factor of 4. So again, I'm going to graph the parent. The natural log button is right here next to the 4 key. So there's my natural log, and you can see what it looks like. An asymptote there at the y-axis. And we type in our actual problem. It's 4 times the natural log of x minus 4, close parenthesis, plus 3. And all of these shifts should be happening here. We should be going up 3, right 4, and it gets stretched out. You can kind of see the stretch there. But the main thing you want to see is the asymptote has been shifted from the y-axis to x equals 4. And then we can verify this by looking at the table. So if I go to second graph, you'll notice you get an error message for all these x values, because all these x values are to the left of the asymptote. But once you get to x equals 5, you start getting numbers again. So 5, 3. And maybe get a couple more points. About 7, 7.3. Just estimating here. And 8, 8.5. And of course, the graph doesn't stop at x equals 5. It gets really, really close to x equals 4 without ever actually touching it. So our asymptote there is at x equals 4. The domain is everything greater than 4. So from 4 to infinity. The range, all real numbers. This graph is going up and down infinitely. And that's how you label the key characteristics of these graphs. Reach out to me if you have questions. If you're struggling with this can be difficult to comprehend. It definitely helps to have a graphing calculator though.